Alright students, let's get started on our module 1.2, and in that the scenario is there's a high school student Marco, and he created this logo for his website, and what he did, he is playing with different sizes of that eye logo for his eyesight. So we need to find a pattern in that logo design. So then let's find out what's happening. So if the size 1, that means your n is 1, then in that case, if you count, you have 7 of them. So you will say when f of 1, then there's 7 of them. Then what happens in the next one is your n is 2, and then if you count them, then in this time there are 1 2 3 4 5, so 10 11 12. So 5 of 2 is 12. And if you think about it, so these you already have from the previous one. So you added 1 here, 1 here, 1 at that corner, 1 at that corner, and 1 at that corner. So you can also say that when it was f of 2, then you had 7 and you added 5 more. When it was f of 1, then you had 7 of them and you did not add anything, right? Then you can also say that if n is 1 and you did not add any 5, you can also write 5 times 0 is nothing. Okay, then which is, if you think about it, this is 1 less from what n is. Now you can also write this down as you have 7 of them initially, then you added 5 more, which is, if you write it 5 times 1, then that is 1 less from n. Okay, so we are trying to find a pattern here. Then let's do the next one. So we initially we had again 7. Okay, so then this time your n is 3, and then if you count all of them, so f of 3 will be 17. There are 17 of them, because if you think about it, you're so 1 2 3 4 5, this is what you added here, but this time you're adding 1 more, so you're adding another set of 5 to that. So we will write this down: 7 plus, so this time earlier we had 5, then we had 5 more this time, so we can also write it down as 7 plus, now you're adding 10 of them in this one, so you will say 5 times 2, which is again 1 less from the 3. So if this pattern continues, then so you added 3 on this side, 3 here, 3 here, 3 here, and 3 here. So you added a set of 5 here, then a set of 5 here, and a set of 5 here. So this time we will be writing f of 4 is 7 plus, and then there are 3 sets of 5, so we will say 5 times 3. When n is 4, okay, and then f of 4, and then that will be 22 of them. So now let's find a pattern. If this keeps going, then you can also write it down as f of 4 is 7 plus 5, and instead of writing 3, if you want to use the n, which is 4, so you will say 4 take away 1, which is nothing but 3. Here we will say f of 3 equals 7 plus 5, and then times 3 take away 1, which is again 2. Here we will say f of 2 is 7 plus 5 times 2 take away 1, which gives you 1, and the same thing we'll do here. So if it is f of n, then in that case we will write down 7 plus 5. Now whatever n is, that will be coming here, so we'll say n take away 1, because it's every time this number is 1 less from whatever n is. So basically here we pretty much figured out what is our formula for for this pattern. So then now let's go to next one, and it is asking how many squares will be needed to create the size with 100 size of 100 squares in the logo. So let's find that out. So in this one we will say n is 100, so we will say f of 100 is 7 plus 5, and then it will be 1 less, so we do 100 take away 1, which is 7 plus 5 times 99. Okay, and then when you multiply these two together and then add 7, so then you will be getting 502 squares in the logo. Okay, so this is how we figure it out. And then so what here we figured out was our explicit rule. Okay, then if we want to figure out the recursive rule for that one, then this is how we will be doing it. So for recursive, remember from math 1 we used to have two equations. The first thing it tells it is starting from what, so this is starting from when n is 1. When n is 1 there are 7 of them, so this is how it starts. Then we need to figure out a pattern each time what is it that we are adding in the previous one. So look how we figured it out, that each time there are 5 extra, 5 extra, 5 extra. So all you're doing is you're adding 5 to the previous logo. So how do you say previous in math? You say f of n minus 1. That means the previous function or previous term. So for this, the previous one is this one. So look how, if this is 2, this is 1 less, so it's n minus 1 basically. So this is how you say previous term, and all you are doing, you're adding 5 to that. So this is our recursive rule for this pattern. So we have explicit rule and we have recursive rule. Now let's find out what is it asking in the next one. Okay, it is saying develop a mathematical model for the squares of the logo of size n. So let's also do this with the table. So let's draw this. So we will be needing 1 for n, then another column for f of n, and then let's find out its first difference. So we will see if first difference doesn't make sense, then we will find out the second difference. So let's see what happens. So it starts with 1 and there were 7 of them. Then in the second one there were 12 of them. And then when it was 3, then there were 17 of them. And with the fourth one there were 22 of them. If we do 5, then basically you're adding 7, so you're adding 5, sorry, so that will be 27. So the pattern keeps going. So when we find first difference, so we do 12 take away 7 and you get 5. So basically you're adding 5 each time. You're adding 5, you add 5, you add 5 each time, correct? So then we figured out already that our explicit was, so we did f of n, okay, and then so it's right here, we just did that. So then we did f of n and 7 plus 5 times n take away 1. If you simplify it, that will be 7 plus 5n minus 5, and so I just multiplied this inside using distributive property. So then we got 5n plus 2. So that is our mathematical model for it, which is nothing but figuring out the explicit rule, which we did anyways. So that's that. Now let's draw this. Let's make the graph for it. So think about it. This will be our n